Hello everyone, thank you very much for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot, you want cookie? And welcome to SAT, ACT Prep. This is live stream 3 of the miscellaneous practice problems. So we're going to go through some clusters of advanced SAT problems with multiple examples so you get the gist. If you have any questions, please let me know either in the live chat function or you can always drop a comment in the comment section below if you're watching the recording. Let me share my screen with you. And just a reminder, these are live sessions, so there's a little bit of a delay, but I'll mitigate that as much as possible. And let's go ahead and get started. So question number 1, a circle is inscribed in a square. If the radius of the circle is 3 inches, what is the area of the square? Number 2 asks, a square is inscribed in a circle. If the side length of the square is 4 inches, what is the area of the circle? So just some preliminary definitions here. Inscribed has a very specific meaning in math. So it does mean, of course, drawn inside of. But it also means that the inside shape is tangent to the outside shape, and tangency means that it touches at exactly one point. So for example, if we're talking about a square inscribed in a circle versus a circle inscribed in a square, so a square inscribed in a circle, a square drawn inside of a circle. So the circle is going to be on the outside, and pardon my terrible drawing ability. And the square would be on the inside, so something like that. Now there are some characteristics to observe. Notice that the diagonal of the square is the same thing as the diameter of the circle. Fix that. Now for a circle inscribed in a square, now we're going to have a square on the outside and the circle is going to be on the inside. I want to try and make that so it touches exactly as much as possible. So the common characteristic here is the diameter is equal to the side length of the square. So I just wanted to let you know before we get started in 1 and 2, but I'll give you 3 minutes for each question, and then about 2 minutes in, I'll start to solve. I'll keep track of the time in the upper right-hand corner, and I'll update it every minute. Okay, so looking at number 1, if we have a circle inscribed in a square, that means that the diameter of the circle is equal to the side length of the square. So if the radius of the circle is 3, then the diameter of the circle has to be 6, which is twice the radius. So if the diameter is equal to 6, and we know that the diameter is the same as the side length, then the side length of the square has to be 6 units long, and therefore the area of the square, which is side length squared, is going to be 6 squared, and that's going to be 36, which is answer selection D. And I'm hoping that we didn't have any trouble with the answer selections for number 2, so let's go through this. A square is inscribed in a circle, so now the diagonal of the square is equal to the diameter of the circle. So they say the side length of the square is 4 inches. So we need to use the Pythagorean theorem here. You can use two different things. You can either use the Pythagorean theorem, which is a squared plus b squared is equal to c squared, or whenever you're dealing with a square, whenever you split a square by its diagonal, that's going to produce two 45, 45, 90-degree triangles. Those are special ratios. So there's two different, this is totally separate, but this is essential information for you to know for the SAT and ACT. There are two types of special right triangles that have exact angle to side proportionalities, and that's the 30, 60, 90 right triangle and the 45, 45, 90 right triangle. So these are really special because if you know that it's a 30, 60, 90 or a 45, 45, 90, if you just know one side length, you can always solve for the other two. And that's a lot more fruitful than just the Pythagorean theorem can be, because with the Pythagorean theorem, you need two of the variables in order to solve for the third. If you have two unknowns, you can't solve using the Pythagorean theorem without more information because you'd have two unknowns. So you could solve for it in terms of the other side, you could solve for one variable in terms of the other variable, but you're not going to be able to get an explicit value. The ratios here, and these will be given to you on the SAT, they will not be given to you on the ACT. If the angles are in a ratio of 30 to 60 to 90, the sides are in a ratio of 1 to root 3 to 2. If the angles are in a ratio of 45 to 45 to 90, then the sides are in a ratio of 1 to root 2. So if I know that the sides here are 4, I'm going to take this ratio. The first step is always to just copy down the governing ratio, because that's never going to change. If you know you're dealing with a 45, 45, 90, then you know that their side lengths are in a ratio of 1 to root 2. So copy down the ratio, and then you can draw a line. The given side lengths of 4 are opposite the 45-degree angle. So I'm going to put 4 underneath the ratio elements that correspond to the 45-degree angles. Now ask yourself, to go from 1 to 4, what do you need to multiply by? 4, right? Because 1 times 4 is 4. So you need to multiply by 4 as a common multiple to get the actual values from the ratio elements. So this missing side length is going to be 4 root 2. And 4 root 2, if you take the square root of 32, we've been practicing a lot with factorization. Notice that 32 breaks down into 4 times 8, which breaks down into 2 times 4. So it's basically just 2 to the 5th power. It's a whole bunch of 2's in here. So this is the same thing as 2 times 2 times 2 times 2 times 2. 5 2's underneath the radical. And for every pair, you can bring 1 outside. So this does in fact turn into 2 times 2 times the square root of 2, which is 4 root 2. So that's the same thing when we got, if we did the Pythagorean theorem, you might have gotten the square root of 32 as the diagonal. So I just want to show you that that's exactly the same thing as 4 root 2. Now if we take 4 root 2, what is 4 root 2? That is the diameter of the circle. But we don't want diameter, we want radius. The radius is half the diameter. So if the diameter is the square root of 32, or in other words, it's 4 root 2 over 2, then the radius is going to be the square root of 32 divided by 2. So if the diameter is the square root of 32, the radius has to be half of that. So if we plug that guy into the area equation, area is equal to pi r squared. I'm just going to use the simplified form to show you as well that it turns into the same value. So squaring inside of the parentheses, you need to make sure that that square goes to the 4, goes to the root 2, and goes to the 2 in the denominator. So squaring here, that's going to give me pi times 16 times 2 over 4. And that's going to be pi times 32 over 4 is 8, so that's 8 pi. So I do apologize, there's a typo in these answer selections. The answer should have been 8 pi. So that should have been available. I do apologize. If there's any questions, please let me know. Otherwise, let's take a look at 3 and 4. Number 3 asks, a circle is inscribed in a square. If the radius of the circle is 5 inches, what is the area of the square? Number 4 asks, a square is inscribed in a circle. If the side length of the square is 8 inches, what is the area of the circle? So I'll give you 6 minutes. After 2 minutes, I'll start to solve. Okay, so for number 3, if we know that the radius of the circle is 5, then the diameter of the circle has to be 10. If the diameter is 10, we know from the circle being inscribed in the square that the diameter has to be the same length as the side length of the square. So by finding out the diameter of the circle, we now know the side length of the square, so we can calculate area. Area is equal to side length squared, so that's going to be 10 squared, which is 100. For number 4, we have the opposite of that. We have a square inscribed in a circle, so we're going to have to either use the Pythagorean Theorem to solve for the diagonal there of the bisected square. So whenever you split a square by its diagonal, it's going to produce two 45, 45, 90 degree triangles. And apart from them being 45, 45, 90, they're definitely right triangles because all the angles in a square are 90 degrees. So we could use the Pythagorean Theorem or the special right triangle ratio. I use the ratio here. That's going to save you a lot of time, and there's going to be some questions that they ask that require you to use the ratio. For example, if they only give you one side, you can't, like I said before, you can't use the Pythagorean Theorem. So you do want to start to get comfortable with using these special right triangle ratios. And we're going to get a lot of practice with them. So finding out, if we line up the given values against the corresponding ratio elements of 1, 1, and root 2, notice that to go from 1 to 8, you need to multiply by 8. So 8 is the common multiple that makes the ratio, converts the ratio from its written values into the actual values of the triangle. And so the side lengths are going to be 8, 8 to root 2, 8 to 8 to 8 root 2. And the hypotenuse of that triangle, which is also the diagonal of the square, which is also the diameter of the circle, is 8 root 2. If the diameter of the circle is 8 root 2, then the radius of the circle is 8 root 2 over 2, which would be 4 root 2. If the radius of the circle is 4 root 2, then we can plug it into the area equation for a circle, which is pi r squared. So pi times 4 root 2 quantity squared is going to be pi times 16 times 2. 16 times 2 is 32, so we're going to have an answer of 32 pi. If you have any questions, then please let me know. Otherwise, let's take a look at 5 and 6. Question 5 asks, a circle is inscribed in a square. If the radius of the circle is 7 inches, what is the area of the square? Number 6 asks, a square is inscribed in a circle. If the side length of the square is 9 inches, what is the area of the square? I'll give you 6 minutes, and 2 minutes in, I'll start to solve. Okay, so number 5, if we know that the radius is equal to 7, then the diameter has to be equal to 14. If the diameter is 14, that's the same thing as the side length of the square, so we can calculate the area of the square to be side length squared, or 14 squared, which is 196, and that's going to be answer selection B. And for number 6, I apologize, those denominators were supposed to be 2's, so I did make that quick change. So I do apologize about that. But if we had a square inscribed in a circle, then the diagonal is equal to the diameter. If they say that the side length of the square is 9, then we know that the hypotenuse, or the hypotenuse of the triangle that square is bisected into, or one of those triangles, which is also the diagonal of the square, which is also the diameter of the circle, has to be equal to 9 root 2. Basically, you might be seeing a pattern here with a 45, 45, 90 degree triangle. Anytime that if you have the side length, the hypotenuse is just going to be, if you have one of the short legs, they're both the same length because it's an isosceles right triangle. But if you have one of the smaller legs is what I'm trying to say, then the hypotenuse is always just root 2 times larger. So if the side length here is 9, then the hypotenuse is 9 root 2. So that's the diameter. We need the radius, so the radius is half of the diameter, so that's going to be 9 root 2 over 2, which is kind of an odd number to work with. However, inserting that fraction into the formula equation for the area of a circle, we get pi times 9 root 2 over 2 quantities squared. Make sure that exponent gets applied to everything inside of the parentheses. And that's also true. We don't have a pi inside the parentheses here, but I have seen that many times on a lot of different SAT problems that they like to put pi inside of parentheses for you to square. A lot of students will skip over squaring or exponentiating pi, and they'll just concentrate on raising the numbers, the actual numeric values to the powers. But just make sure everything inside of parentheses that's getting raised to exponents gets, all of it gets exponentiated. So 9 squared is 81, root 2 squared is just 2, they're opposite operations, so the radical cancels, and 2 squared is 4. We can reduce the 4 in the denominator by the 2 in the numerator, and so that just becomes 81 over 2 times pi, and that's answer selection A. If you have any questions, then please let me know. Otherwise, let's look at a brand new pair of questions. And let me resize my camera a little bit so you can see all of that. Okay, number 7. An alphanumeric code is given to every employee at a particular job site. If the code must either be 2 numbers, 0 to 9, or 2 letters, A to Z, how many 2-digit codes can be generated if repeated values are allowed? So, for example, it would be allowed to have a code 44 or CC. So there's just saying that you're allowed to repeat values. Number 8 asks, a restaurant serves 5 different appetizers, 8 different entrees, and 6 different sides. How many unique combinations of 1 appetizer, 1 entree, and 1 side order are possible? So I'll give you 6 minutes, and in about 2 minutes in, I'll start to solve. So these are problems relating to combinations and permutations. So I would think about how many options you have in each number or letter position, and think about what mathematical operation you would need to do to those values in order to calculate the total possible arrays or combinations. So 6 minutes, and then we'll review. Okay, so 7 and 8 involve combination and permutations. So there are formulas for combinations and permutations, but they're not really that relevant here, and it's a lot easier to solve, I think, just by examining the context of the question. So you want to think about how many options in each position you have. And if you are adding multiple conditions, so if you have to be this and that, that's multiplication of those percentages or of those factors. If it's this or that, then you have the option of this or this one or that one, or this characteristic or that characteristic. Like in number 7, it says it can be 2 numbers or 2 letters. That's addition. So you have to calculate those probabilities separately, or combinations, number of possibilities separately, and then add them together at the end. Whereas number 8, we're talking about one after the other, one being, so each combination has to have one appetizer, one entree, and one side order. So there it's just straight multiplication throughout of the different possible options at each different type of dish. So 7, we're making codes here that are either 2 numbers, 0 through 9, or 2 letters, and they also tell us that repeated values are allowed. So we could have a code like 44 or CC. So when repetition is allowed, that's a combination. If repetition is not allowed, if you can't use the same number or letter twice, then that's a permutation. And that just affects the numbers that you choose to multiply with or by. So the first code would be 2 numbers, 0 through 9. So those are 10 digits, 0 through 9. So at each of those 2 number positions, you have 10 options. Now for letters, however, there's 26 letters in the alphabet. So you have 26 options at each position for the 2 letter codes. So we have 10 times 10 plus 26 times 26 options, and that's going to give you 776 unique 2-digit numeric codes or 2-digit letter codes. I should say 2 letter codes, not 2-digit letter codes. But the answer to 7 was 776. For 8, we're just going to multiply the different options we have available at each classification of dish. So how many appetizers times how many entrees times how many side orders they have. So 5 times 8 times 6 will give you 240 different options. If you have any questions, then please let me know. Otherwise, let's look at number 9 and 10. So 9 asks, an alphanumeric code is given to every employee at a particular job site. If the code must either be 2 numbers, 0 to 9, and a letter, A through Z, or just 2 letters, how many codes can be generated if repeated values are not allowed? So now I'm not allowing you to use repeated value, or this place is not allowing you to use repeated values. So take 6 minutes and attempt, let me read 10. Number 10 says, a restaurant serves 9 different appetizers, 8 different entrees, and 7 different sides. How many unique combinations of 1 appetizer, 1 entree, and 1 side order are possible? So take a few moments, 6 minutes, and solve those problems, and then we'll review. Okay, so the difference between a permutation and a combination is the fact of whether you can use repeated values or not. So what that means is once you use 8, you can't have 8 repeated twice in a code, or 2 or 3, any number you can't repeat. So that means that you necessarily each time are taking away one possible value that you could use for the next position. So you just need to subtract 1 for each subsequent number or letter after the first. So in the first code, the code can either be 2 numbers and a letter or just 2 letters. So for the first 2 numbers, at first I have all 10 digits, 0 through 9, to work with or to choose from. But when I go to the second number, the second actual numeric value, then I can no longer use the value that I used for the first position. So in that case, now I'd have 10 minus 1 or 9 possible values to use. And then I have just 1 letter, so I have the full 26 letters in the alphabet to choose from. I'm going to add to that because it could also just be 2 letters, but again, I can't repeat the letters. So at first, I have 26 options to choose from out of the 26 letters in the alphabet. But when I go to choose the second letter, I no longer have that first letter as an option. So I need to subtract away 1 from the total number of letters that are possible to choose. So I'm going to have 26 minus 1, which is 25. 26 times 25 is 650. 10 times 9 times 26 is 2,340. 2,340 plus 650 is going to be 2,990. If you have any questions, then please let me know. Otherwise, let's look at number 10. So if the restaurant serves 9 different appetizers, 8 different entrees, and 7 different sides, here, this is a combination. It didn't say anything about repetition or order, and we're just talking about 3 totally different classifications of food items here. So we're just going to multiply the different possible items within each category together. 9 times 8 times 7 is 504. So our answer to number 10 is 504. Again, if you have any questions, then please let me know. This last pair is going to bring us up to the end of class today, so we'll end a little bit early for today's session. But number 11 asks, an alphanumeric code is given to every employee at a particular job site. If the code must be 3 numbers, 0 to 9, and 1 letter, A to Z, how many 4-digit codes can be generated if repeated values are not allowed? Number 12 asks, a restaurant serves 7 different appetizers, 14 different entrees, and 5 different sides. How many unique combinations of 1 appetizer, 1 entree, and 1 side order are possible? So I'll give you 6 minutes, and that'll bring us up to the end of class today after we review. So I'm so sorry the answer grid got flipped around. So I meant for 11 to be grid in, and the answer selections to 12 are actually for 11. So I'm so sorry. But the answer to number 11, since we have a permutation here, we're not allowed to repeat values for the second and third letter, second and third number. At first, we have 10 different options available, 0 through 9. For the second number, though, we're going to have 10 minus 1 options because we can't use that first number again, so we'll have 9 values we can use. For the third number, we're going to have 8 values we could possibly use. And then we need one letter, and we have all the letters in the alphabet, so that's going to be times 26. So 10 times 9 times 8 times 26 is 18,720, which is answer selection B that's listed in number 12. So I do apologize about that. It got mixed around here. And then for number 12, if we just multiply the different possible number of appetizers, entrees, and side orders, then we have 7 times 14 times 5 is 490. So I'm going to write that up here in the grid-in that's listed under number 11, but I do, again, apologize. It's supposed to be for number 12. So number 12 is 490. Number 11 was 18,720. So please let me know if you have any questions on anything that we've done today. I will be putting out some more videos, so watch out for that. But otherwise, thank you very much for signing in. I really appreciate it. And Dr. Tot, do you want to say goodbye to everybody? Let's see if he can say goodbye. Do you want to say goodbye today? Come on, let's say goodbye. Come on, you got to work. He's been getting very lazy lately, so I don't know. Can you say bye? Can you say bye? There we go. Well, thank you guys very much for watching. I hope you have a wonderful weekend, and I'll talk to you all on Monday.